In this lecture, we are going to discuss about how to find the relative error and absolute error in the fundamental operation of arithmetic. Okay, and particularly we discuss here for two operations. The first is multiplication and the second is division. And we already discussed for addition and subtraction in our previous classes. Okay. Now, if we consider a function u, this is like, since it is multiplication, so this is like u1 into u2 to un. Okay. Then to find the relative error and absolute error of u, we take first both sides, we take logarithm. That is log u, this is equal to log of u1 plus log of u2 plus this is log of un. Okay. Now, as the formula of derivative, we write here, this is delta u by u, this is equal to delta u1 by u1, this is equal to delta u2 by u2, and the last is delta un by un. Okay. So we taking logarithm on, so we take mod on both sides and get mod of delta u by u. This is less equal to mod of delta u1 by u1 plus mod of delta u2 by u2 and so on. This is mod of delta un by un. Okay. So we know that this is the this is the relative error er, this is equal to delta u by u. Okay, and this is the maximum value of relative error, that is the maximum value of relative error. Okay, and if we want to find the maximum value of absolute error in this case, then we know that EA, this is equal to EA, this is equal to ER into VT. Okay, this is the true value of u. So we get the maximum value of relative error. This is given by EA, this is equal to mod of delta u by u into true value, this is u. So u cancel out, that is mod of delta u. Okay, so the maximum value of EA, this is given by, this is delta u1 by u1 to delta un by un into mod u, or simply u, because u is taken to be positive. Okay, this is the maximum value of absolute error. Okay, this is the relative error and this is the absolute error. Now for the second case, that is for the division, here we take the function u, this is u1 by u as the quotient of two functions. Now here also we take logarithm on both sides, log u, this is equal to log u1 minus log u. Okay, and as similar for as derivative, we get delta u by u, this is equal to delta u1 by u1 minus delta u2 by u2. Okay, so the relative error, this is equal to mod of delta u by u, and this is the maximum value of relative error, this is mod of delta u1 by u1 plus mod of delta u2 by u2. Okay, this is the maximum value of max error. And similarly, as in the first case, we get maximum value of relative error er, this is less equal to, this is maximum value of absolute error, this is less equal to er into u. So we get less equal to mod of delta u1 by u1 plus mod of delta u2 by u2 into u. Okay, this is the max EA, that is the maximum value of absolute error. Now to betterly understand these two facts, together we consider an important example and which is also from your previous year question paper. The problem is, if u of xyz, this is equal to xyz square. This is the function of xyz, and the error in xyz are three errors are given here. Three errors are given, that is the absolute error of x, this is delta x, this is equal to 0.005, delta y, this is equal to 0.001, and delta z, this is equal to 2. Okay, these three errors are given. At the point x equal to 3, y equal to 1, z equal to 1. We have to compute the maximum value of absolute error in evaluating u at 3, 1, 1. Here the point x, y, z, this is given by 3, 1, 1. We first find the true value of u, that is u of 3, 1, 1. This is given by 3 into 1 into 1 square, this is 3. Okay. Now here we take u, this is x, y, z, and take logarithm on both sides. We get log u, this is equal to log x, log y plus 2 into log z. And this relation gives delta u by u, this is equal to delta x by x plus delta y by y plus 2 into delta z by z. And we know that relative error ER, this is given by mod of delta u by u, and whose maximum value is less equal to mod of delta x by x plus mod of delta y by y plus 2 into mod of delta z by z. Okay, and this is given by, here this is given by 0.005 by this is 3 plus, and this is 0.001 by y means 1 plus 2 into 0.002 by 1. Okay, and this is given by 0.00166, this is 0.001, and this is obviously 0.004. So we get this is 0.00666, and this is the maximum value of relative error. Okay, but here we have to find the maximum value of absolute error, not relative error. So using the formula of absolute error and relative error, this is ut, that is the true value of u. We already find the true value of u, this is equal to 3. So maximum value of relative error, this is given by, we put here the maximum value of relative error, this is 0.00666 into this is 3. So this is 0.01998. Okay, and EA, that is the maximum value of absolute error, is this. So our answer is EA max is given by 0.01998 in computation of u at the point 3, 1, 1. Okay, this is very, very important and interesting problem of error. Okay, thank you for watching.